Yeah.
Function.
Can you write a little bigger?
Yeah, I was about to say that.
Can you try writing a little bigger?
Modular.
Sorry, sir. This is not.
Okay, so as he's writing, while he writes, what is the what would be the function signature, or how do you think about this problem? That's what I want to understand. I mean, let him don't pay attention there for now. So let's think how to.
So at each level, we need to check if the left child, if the false condition is like if left child is greater than the root value, return false.
Right. So that is correct. So you are trying to say if the left child is lesser than the root, and the right child of the root should be greater than the root, basically. So if I had let's keep this as 2 and let's keep this as 4. So this satisfies the primary search tree property, right?
Yes.
Now instead of 4, if I had 8 here,
Okay.
what happens?
So at 3, okay.
So if you just go by this and say, I'll put some data number here, and if I say my left child is less than me, my right child is greater than me,
then
and if I limit it, it becomes like a, you are limiting it to that particular scenario. So you need to make sure that it is like a global thing. That is, so that's why the whole question of the range is coming into play, where we're trying to say that we need to find what this should exceed from here, from your left tree. So that's where even I was having the challenge initially when I was writing. My definition was also getting limited by the simple definition, but that definition has to kind of be taken up the tree. As you go and figure it out, it has to be taken up. How do you do that? So you need to find out. Is that disturbing you?
No.
You can. So you need to figure out that. So 5 has to be greater than the maximum of this, right? And 5 has to be less
than the minimum
of this, right? That means we need 2 more arguments or 2 more values to be able to determine that it is a BST at a uber level. That's what, if you look at it, Otherwise, if you're just looking at it internally, even a tree like this with a local definition will say it is a binary search tree while it is not. Correct? So this lends itself to having 2 arguments extra, which is the min and the max. You're trying to get that range. So you're getting the max of your left subtree. If I look at the root, right, I'm trying to find the max of the left subtree and check if 5 is greater than that, and I'm getting the min of the right subtree and check if 5 is less than that. And I will apply the same definition to every tree, every subtree that going forward. Does that make sense?
So, like to start off with, so here the allowed range is input min and int max. When you traverse down here, the allowable range, the maximum is defined by 5, so it will be 5 and int min. Going further down here, the range will be int min and 3. So now moving to the right, the range here will be 3 and 5. So first check is to make sure this value is within that range, and then continue that check with the child node. Similar thing here, while traversing here, the allowable range is 5 will be the minimum and int max. So once you apply that property, you should have a helper function to keep track of the min and max possible value. And as you traverse each child node, you adjust that value.
So is that clear? I mean, he was very lucid in explaining what. So that's great. I mean, that's good. well explained. Especially this, I think, clarifies.
Mhm.
So initially, so when you pass, so when you call this, what are you sending?
So I'll send the root
Int
root
min.
and the max and the min.
Max and min.
And at each next level I traverse, I'll adjust it to the current value whatever I have to do.
So you're saying return root of val is less than?
So this is basically a big if statement. Like first check. Yeah.
Okay, if it is less than the less than or equal to the max, that means you're getting the max from here, and this is if it is less
R
than
max
equal
will
to
be like the
and that
parameters.
is
Yeah.
greater than the R min. Okay, okay. Then root of left R min, root value, root of right, root value R max. So you are returning isBST this one. Okay.
So each time you move to the left side.
Oh, you've just condensed the whole thing.
Yeah, I've
into
just
an and.
condensed it. So this will be
Okay.
like one if statement to check, hey,
Okay.
is this within the range?
Yeah. Is that clear to everyone? Thank you, Sanjay. Yeah. So is this clear to everyone? Why is it min and max and I mean, so you know, if you're only looking at 5, then 5 can have, it's just one node, so it can be anything. But then when you come to 3, then the fact that there is 5 on it, the 5 is the parent, it gets limited by 5, but 3 can also be anything less than 5. That's why the 8 min is still there. And then, first of all, why did we need ranges? I hope that is clear, because that's what I was trying to explain. You cannot just take left and right and just say this root is greater than or less than and then just decide. You need to have a range to check that the BST property satisfies recursively all the way to the top. So that's why you need the range. And the same property applies here. So the minimum is getting limited by 3 here because this has to be greater than that, and the maximum gets limited by this. So that's why. So as you go down, your ranges become limited. As you go up, the range kind of starts expanding. And so when you're at the leaf, basically you're saying that the binary search tree is satisfied, right? You're at a leaf, it's fine. So you're just returning true because it's a Boolean function that you're returning. Else you're just checking if the value is less than the R max. So initially if you start with 5, you will say the root of, so root is, it's not null, so you'll say the value, is it less than the max? This is R max, this is the maximum value, which is the integer max here. It is less than or equal to, and if the integer value is less than, it's greater than the R minimum, yes, and you're checking. So then the fact that it is lying in this range, you're going down to the next node and you are trying to limit. Now you're trying to say that, now I'm getting limited by 5 on my right side, which gets passed here as root value. And the R min remains your int min. And you'll do this. So essentially this will eventually return a Boolean function, but he has condensed everything into a single return statement. We could actually put separate if conditions, and I think that will clarify it even better, but I could write that down if you need clarification on how to write it separately. This can get a bit confusing if
would that be like if the value is between min pass and max pass?
Yes.
If the value is not between min pass and max pass,
okay.
return false. Else assign the new value to the root.
Yes.
That will be if and else statement instead of
Correct.
that compound statement.
Yes.
So if the value is between the min pass and the root, then
Yeah,
you assign the
the
value.
if, right? Yeah, the if, I think the if condition will be.
Instead of return, you can just put a if and return.
Yeah, you can write it
Then
there.
only.
In this mode.
Here?
Yeah, and then
You need to write 2 lines,
So
right? So
instead
you have
of
to
positive,
check
we are just writing.
then instead of return if, and then return should go below at the third line.
You want me to erase that?
No?
Oh,
Yeah,
instead of,
yeah,
okay,
yeah,
just
yeah.
make it if. Okay.
If, yeah. if, then first two condition. So this
And
is-
And no,
The
if
same
this is
thing.
less than this one,
and
the
or-
fact that it is okay, lesser, okay, it is.
So
So
remove
you'll have,
the
or
remove
what
the
we could do is
second
we have to
and
reverse the conditions and return false, right?
Yeah.
That's what you will want to do.
So value
Go
is
ahead.
greater than max,
Yeah.
and value is less than greater.
so I think what thing is
yeah,
Yeah.
exactly.
No, that's
if
what. But
this is the
then
case, then
return true will become. So you want to return false. So that's what I'm trying
So
to say.
you have to
want
either do
reverse
not or change the condition.
Yeah, if
Yeah,
not,
not or
return
change the
false.
condition.
Yeah, not.
Okay.
Yeah. Yeah.
so
Value
this,
is
Keep the not.
greater than
remove-
max.
Yes. Remove the not. Yes.
this
Yes.
value is
And-
greater than
Yes.
it's less than,
Yes. It becomes a not.
then return false.
So it should be less than equal to, right?
Yeah, it should be less or equal to.
So
Less
this
than
would be
equal.
the range check,
Yeah.
and then this would be the child.
Yeah, it just should be less than equal.
Less than
to.
equal to.
That's it.
Yeah.
Yeah.
I think this is more clear now. It's just like this becomes a complete range check,
Mhm.
and then you're returning.
Recursively calling.
Yeah,
Recursively
you're
calling.
recursively calling, and this will be an AND function, right? Because
So
both should
left
satisfy.
and right should.
Should be a BST. That's why it should satisfy. So this is an AND. But here, the minute one particular function, fails, that means so the failure condition is with OR, and the true condition comes with the Boolean AND. The AND. Yeah.
Got about 40